Dear learners, in this video, let's learn about the structure of internal RAM of 8051 microcontroller. The 8051 microcontroller has 128 bytes of on-chip, that is internal RAM, and along with internal RAM, it also has 4 kilobytes of on-chip, that is internal ROM. Internal RAM is used to store temporary data, and internal ROM is used to store the programs as well as permanent data. In this video, we will mainly focus on the internal RAM. So the 8051 has 128 bytes of internal RAM and the addresses range from 00H to 7FH. If you convert this 7F in decimal number, then it comes to be 127. So 0 to 127, it means that 128 bytes of internal RAM is there. This internal RAM is divided into three different groups. The first one is register banks, second one is bit addressable RAM, and third one is general purpose RAM. So this shows the structure of internal RAM. You can view here that the first group is register bank, and it is divided into four different banks: bank 0, bank 1, bank 2, bank 3. Each bank has 8 registers and they are named as R0 to R7. In this way, 4 banks has 4 into 8, that is 32 registers. So these 32 bytes are occupied by the first group of register banks, and the addresses range from 00H to 1FH. The second group is bit addressable RAM, which resides exactly above the register bank, and it ranges from 20H to 2FH. So in total, it has 16 bytes: 20H, 21H, 22H up to 2FH. The speciality of this RAM is it is bit addressable as well as byte addressable. Means if you take the example of say 20H, then it can be used as a whole 8-bit memory location where 8-bit data can be stored, or I can store a single bit in any of these bits. Say address 01, I can store any data. Address 02, I can store any data. So in total, 16 locations are there, and each location has 8 bits. So 16 into 8, 128 bits are available if I am using it as a bit storage area. And if I am using it to store the bytes, then I have 16 bytes ranging from 20H to 2FH. And the third part is general purpose RAM, and it spans from 30H to 7F. It is used for general purpose, and in total it has 80 bytes. So in short, 32 bytes of register banks, 16 bytes of bit addressable RAM, and 80 bytes of general purpose RAM forms 128 bytes of internal RAM. Now let us go in detail to each of the group. The first group is register banks. As I have already told you, 4 register banks are there. They are named as bank 0, bank 1, bank 2 and bank 3. Each register bank has 8 registers. Remember, each register bank has 8 registers, and these 8 registers are named as R0, R1, R2, R3, R4, R5, R6 and R7. Now on reset or by default, bank 0 is selected. Now what is the necessity of selecting the bank? We will discuss it. The area above bank 1 onwards can be used as a stack. So stack pointer is by default at 07. So area above bank 1. Bank 1 starts at 08 address. So 08 onwards we can use it for stack memory. This shows a broader picture of register banks. On the left hand side, you will find that 00H to 1FH. These 32 locations, they are occupied by 4 different register banks. They are bank 0, bank 1, bank 2 and bank 3. And on the right hand side, you will see that all those registers, they are shown. Say bank 0 comprises of R0, R1, R2 up to R7. Similarly, bank 1 comprises of R0, R1, R2 up to R7. Bank 2 has R0 to R7, that is total 8 registers, and similarly bank 3 also has R0 to R7 register. You will find that R0 exists in bank 0, bank 1, bank 2 as well as bank 3. Same is the case with R1. It is in bank 0, bank 1, it is in bank 2 also, and it is in bank 3. The specialty is that the registers also has an address. Say R0 register of bank 0 has an address of 00H. R1 register has an address of 01H. And these addresses are unique. Now remember that R0 is called as in bank 0 is same here in bank 1 also. But the address of R0 in bank 0 is 00H and address of R0 register in bank 1 has 08H. So in total you are having 00H to 1FH, that is 32 different locations for 32 different registers. The registers are named as R0 to R7, but they can be differentiated by mentioning to which bank that register belongs. So if I am talking about say R1 register, then I should also mention that to which bank it belongs, because R1 is everywhere. So I should also mention that R1 of bank 0 or R1 register of bank 2. So same figure is shown here, and the question is now, suppose I am talking about R1 register. Now as it is in every bank, so how I will come to know that to which bank it belongs. So for that purpose we have the facility of RS1 and RS0 bit of PSW register. This is the structure of PSW register, which stands for program status word. Out of 8 bits of PSW, bit number 4, that is RS1, and bit number 3, that is RS0, these two bits are called as register bank selector bits. And as total 4 banks are there, these 2 bits are there. So 2 raised to 2 is 4. So this is the way in which 1-0 combination in RS1 and RS0 will select a particular bank. When RS1 is 0 and RS0 is also made 0, then bank 0 is selected. And the address of bank 0 is 00H to 07H. If I want to select bank 1, then I will make RS1 as 0 and I will make RS0 as 1. I will make RS1 as 0 and RS0 as 1, so that bank 1 is selected and it spans from 08H to 0FH. If I want to select bank 2, then I will make RS1 1 and RS0 0. The address range is from 10H to 17H, which is shown here. And the third bank, that is bank 3, is selected by putting 1 in RS1 bit and putting 1 in RS0 bit. The range of address is 18H to 1FH. Let us go through one simple program. Here I am asked to store the value 78H in R2 of bank 2. What I have to do? I have to store 78H in R2 register of bank 2. So particularly I want to store 72 value here, because this R2 belongs to bank 2. So for that purpose, first I have to select bank, because R2 exists in bank 0 also, R2 exists in bank 1 also, it exists in bank 2 also, and it exists in bank 3 also. So out of these 4 register, I should fix or I should select R2 belonging to bank 2. And for that purpose, what I have to do? To select bank 2, I have to make RS1 bit as 1 and RS0 bit as 0. And these 2 bits belong to PSW register. So for that purpose, what I will do? I will write the instruction setB PSW.4. PSW.4 means RS1 bit. SetB means make it 1. Set it. So this bit is made 1. So RS1 now is 1. The next instruction is clear PSW.3. Clear means make it 0. Which bit? PSW.3. PSW.3 is nothing but RS0 bit. So RS0 bit is made 0. So as RS1 is made 1, RS0 is made 0, obviously bank 2 is selected. And once you have selected bank 2, now you can shift that desired value, that is 78H, into register R5 by writing the instruction move R5, hash 78H. So this is how a value can be loaded in a register of a particular bank. Now let us move to the second section or second group of internal RAM. It is bit addressable RAM. Now as name indicates, this RAM can be accessed in the form of individual bits. So this second group is shown here, bit addressable RAM. It spans from address 20H up to 2FH. So in total it has 16 bytes. So if you count 20H, 21H, 22H up to 2FH, these are 16 bytes. And as these are the 16 bytes and each location has 8-bit storage capacity. 20H location can store 8-bit of data, 21H will store 8-bit of data. Similarly, all these 16 bytes will store 16 into 8, that is 128 bits. So it stores 128 of bit if you are using it for storing the bits. Now, how to handle these bits or how to store data in these bits? So for that, special instructions are there, and these instructions which deals with a bit in bit addressable RAM or bit of SFR, they are called as a Boolean instructions. They are called as a Boolean instruction. What is the job of Boolean instruction? Boolean instructions are used to access any of the individual bits from the bit addressable area. For example, if I have written set B 05H, then this instruction will store, set B means make it 1. This instruction will store 1 at bit address 05H, and 05H will be somewhere here. Now you will wonder that 05 will be also the address of bank 0, but as this set B instruction does not work on byte, it will be definitely 05 will be definitely belonging to the bit addressable RAM. So this figure will make it more clear. Now just I have talked about 05 location. So that 05 location is here. So 05 is here. So when you want to individually store a single bit of data, then you have the choice of using these 128 bits. So bit addresses range from 00 to 7FH. So you can store the data, you can check what data is stored, or you can manipulate the data by using the corresponding instruction. If you want to use it as a storing of 8-bit, then you can store it as a byte addressable memory. Say I want to store 8-bit of data in memory location 20H. Then instead of using individual bits, I can store whole 8-bit data at one go. Means even if the name is bit addressable RAM, I can store it, I can use it as a byte addressable as well as bit addressable. Now what is the benefit of using storing the data at a particular position in bit form? Say I want to store the status of a LED, whether LED in on condition or off condition, or say I want to store the status of switch, whether switch is pressed or not pressed, then that data will be only 1 bit. So there is no need to store the whole, or there is no need to waste the 8 bits if I use it as a whole location. Instead of that, I will use out of 8 bits only 1 bit to store the status. So the memories are saved. So this is all about bit addressable RAM. And the third group in internal RAM is general purpose RAM. So this shows the third group, general purpose RAM. It is also called as scratch pad RAM. It can be used for storing the general purpose. It ranges from 30H to 7FH. The starting address of general purpose RAM is 30H. The ending address is 7FH. In total, it is having 80 byte storage. If you count this 30H, 31H, 32H up to 7F, it will be total 60 byte storage area, and it is strictly byte addressable. It is byte addressable. Register banks are also byte addressable. This area only is bit as well as byte addressable. And finally, above 128 bytes of internal area, there is one more area which is specially reserved for storing the special function register values. So 128 bytes of additional on-chip RAM. It is above 128 bytes of internal RAM. So this additional 128 bytes of on-chip RAM, which ranges from ATH to FFH, it is reserved for special function register. And in this figure, you can view that above 7F, 8H, 80 is there. So 80 is the address of port 0. 81 is the address of stack pointer special function register. 82 is the address of data pointer low. 83 is the address of data pointer high. So in this way, there are special function register which are allocated with these addresses. You will find that on the right hand side, the name is written, say P0, and that special function register also has address 80. So when I want to write a particular data in port 0, I can use the term P0 in instruction, or I can use the memory address 80. Both means same, but using the name is more convenient. So we generally remember the names. The names which are ended with this asterisk, these are special function register which are bit addressable. Bit addressable means I can individually access a single bit out of 8 bits. I can individually deal with a single bit. And those registers which are having no asterisk at the end, they are only byte addressable, that is not bit addressable. So in total, there are 21 special function registers. So if you count them, P0, SP, DPL, DPS, these are total 21 special function registers. And out of 21 special function registers, 11 special function registers are bit addressable. Bit addressable means I can individually store a single bit in a particular 1 bit position out of 8 bits. I can check the status of individual bit out of 8 bits without disturbing remaining bits. So that is the meaning of bit addressable. And these are the special function register 21. Out of them, accumulator and register B. Accumulator is used in all arithmetic and logical operation. Register B is also generally used in multiplication and division. They are the special function register. DPTR is one 16-bit register which is divided into two 8-bit register. Data pointer high, that is DPH, and data pointer low. So this 16-bit register which is split into two 8-bit register, that is also special function register. Stack pointer, which points to the last memory location in stack memory. So that stack pointer register is also one of the special function register. Program status word, which is also called as flag register, that is also special function register which is having the address D0, which is shown here. There are 4 8-bit ports in 8051 register. They are named as port 0, port 1, port 2, port 3, and they are bit addressable. So you can view that port 0 is having address 80. Particularly P0.0 bit has the address of 80, P0.1 bit has the address of 81H, P0.2 has the address of 82. That's why in bracket these addresses are written. So if you are using individual bits of that register, then use these addresses. If you are using all 8 bits at the same time, then use this address which is written on the extreme left side. So port 0 is there. You will find port 1 here having address 90H. Then port 2 has the address of A0, port 3 has the address of B0. 8051 has the facility of serial communication, and there are two special function registers related to serial communication. They are named as SBUF and SCON. So out of these two, SBUF is not a bit addressable and SCON register is a bit addressable. 8051 has two timers counters, and there are 6 special function registers specially meant for timer or counter related operation. TMOD is one of the special function register. It is not bit addressable, which is used to set modes of timer. TCON is another special function register, which is bit addressable. Timer 0 related count values can be stored in TL0 and TH0 register. Similarly, timer 1 related count values can be stored in TL1 and TH1. So these are the 6 special function registers particularly devoted for timer or counter related operation. And 2 registers, IE and IP. So IE is shown here, interrupt enable register having address A8, and IP register, interrupt priority register having address B8. These two special function register, they belong to the category of interrupt register. And finally, a power control register which is called as PCON register. It has the address of 87H. This is the register which is meant for deciding whether you want to use the power down mode or idle mode of 8051 microcontroller. So this is all about 128 bytes of internal RAM and special function registers of 8051 microcontroller. Thank you.